My name is Matthew Wagisback.
I'm Devin Spellagine.
And I'm Ethan Roche.
And I'm Stephen Bright.
So today we're going to talk about managed pressure drilling and our experimental adaptation to it. So first of all, I'm going to start off with our goals and objectives. So when we first started this project, we realized we were dealing a lot with pressure, so we decided to go ahead and model the pressures in the riser using drill bench and Excel. Since we don't have the license yet for drill bench, we've been looking at it in Excel, and we hopefully, once we have the license, we'll be able to compare our Excel results to our drill bench results. And with these comparisons, we should be able to properly adapt our experimental apparatus to it, right? So with that, we should be able to determine the practicality of the experimental adaptation to MPD through multiple test stages.
Okay, what is MPD? Managed pressure drilling is a drilling technique where we close in the well to the surface so we can apply back pressure. We can more accurately manage the pressure profile of the well. Applications of managed pressure drilling. Right now it's mostly used offshore, but is expanding onshore every day. It's also used mainly in wells with narrow pressure windows where the space between the pore pressure and the fracture pressure is very slim, so you're at a high risk of either fracturing the formation or taking a kick. The two main styles of MPD are reactive and proactive. Reactive is where you drill with the typical overbalanced mud, you weigh it up to adjust for pressure changes, and you have your MPD gear as a safety net in case something goes wrong. And proactive MPD is where you have all the equipment at your disposal to save time, save money, all that good stuff. Just briefly touching on the four methods of MPD. Pressurized mud cap drilling, constant bottom hole pressure, dual gradient drilling, and returns flow control. Pressurized mud cap drilling is mostly used when your formation is at a high risk of losing fluids to the formation. So what we do here is we inject in the annulus either seawater or less expensive drilling fluid, to where when we do lose that to the formation, it's not our mud and we can afford to lose it. Constant bottom hole pressure, as you can tell from the name, is where we adjust that back pressure to keep a relatively constant bottom hole pressure so we can stay in the drilling window for as long as we can. Dual gradient drilling is where we have multiple gradients of mud. One starts from the water surface to the seafloor, one from the seafloor to total depth. This allows us to run fewer casing strings in the well, and again with the pressure window you have a less chance of fracturing or taking a kick because the drilling window you stay in there longer. Returns flow control is a health, safety, and environmental variation. This is one of the reactive forms of MPD, where you drill with overbalanced mud and your typical weighing up the mud, and you have your MPD as a safety net. As far as the process of MPD goes, there are no major flaws or problems, but a few concerns are things like maybe crew training, because your crew members and your drillers are used to just traditional overbalanced mud, and MPD is a newer form of technology, so it takes a little while to get used to the equipment and safety procedures for these new pieces of equipment. Also, cost is a small concern because it's a new technology. It's going to cost a bit more than your normal technology, so maybe smaller companies won't be able to invest in this. Larger companies will have the capital to invest in it and use it to its full advantage. The future of MPD does look very bright. It's being used, like I said, more onshore now as well as offshore. It's just a new standard for safety, for efficiency for drilling. It's becoming very efficient.
Next we'll take a look at the scope of our project, but first we're going to start out with who we're working with. So we have Dr. Almeida, a PhD holder who is a professor in the LSU Petroleum Engineering Department. He teaches our 4045 class, We also have Daniel Braga, a graduate student and TA for 4045. He has industry experience and he came back to LSU to study managed pressure drilling and have a better understanding of it. So he is our go-to guy for this. Our team members consist of 4th and 5th year seniors, and we all have experience with internships and SI leadership. Where we will be working. So we have LSU's Petroleum Engineering, Research, Technology, and Transfer Laboratory. It's a state-of-the-art experimental facility that is able to model multi-phase flow with field-scale apparatuses. Our experiment is located right outside the control room, so we were able to piggyback on their data collection software for our pressures in the model, so we can better analyze them later. And when we're using drill bench, we're going to be in PFT's computer lab, which brings us to the drill bench software. It's offered by Schlumberger, and by definition, it is a dynamic drilling simulation software that is used for simulations with pressure control, well control, blowout control, managed and underbalanced operations. And our hands-on model, the idea behind that one is to determine the feasibility of an injection pump at the top of the riser to safely divert a gas kick in the lower riser. And for our basic schedule for spring, we're looking at getting all our materials in January, as well as learning drill bench software. Most of that will be self-taught. And then in February, we hope to complete the model and start running probably the first iteration or test style on it. And then in March, we should have a complete comparison of drill bench to our Excel file, as well as a completed data set for the apparatus at PERT Lab. And in April, we will be presenting that to our industry and our advisors.
So next we're going to take a look at health, safety, and environmental. So we'll be working a lot at the PERT facility. So of course safety is a big concern. We'll have to watch out for hazards like slips, trips, falls. There's a lot of things that could go wrong. We don't want anyone to get hurt. So we'll have to wear our proper PPE, hard hats, safety glasses, long pants, closed-toe shoes, and of course a positive attitude, right? So we're hoping with our experiment we can improve the work environment in the field. You know, hopefully we'll be able to come up with enough data to help people understand pressures better and understand how to safely divert a gas kick without having to shut in the well, and hopefully we'll make people less worried when they're using MPD practices.
So with our project, we use Excel, drill bench to do results and compare results. But we also need a hands-on model to also gather results, and we need a budget plan for that. So to begin that, we need to set out a basic design of our model to clarify what materials we need, and we'll do that by comparing from different sites, such as, well, materials we need are PVC pipe, gauges, pumps, and epoxy. So we'll go to different sources and compare those prices and give you a rough estimate of the price, being that we didn't create it yet, showing a high cost and low cost range to give you kind of a game plan to how we're going to accomplish our project. And hopefully, and then we'll use our scale down dimensions. So in the field, obviously, the scale is tremendously bigger. So we're doing it at the PERT lab right outside the drill shack. So it's a very small example. So we use scale down dimensions from the book to estimate the amount of materials we need. So.
In conclusion, hopefully our funding will determine the amount of tests we can run. We're hoping we can run multiple test heights from the diverter line. We're also hoping to have multiple flow rates of injection and also multiple different mud weights if possible. And depending on our findings, hopefully it can be built upon by other students after us or grad students, and eventually help out in some way in the field. So again, I'm Matthew Wagasback,
I'm Devin Spellagene.
I'm Ethan Roche.
I'm Stephen Bright.
and thank you guys for watching our presentation. Hopefully it gave you a better look at what we're working on and where we plan to go.